right, so last time we left off on the page right before this problem, and we were looking at being able to sketch in our angle. Let me find our page here. Sorry, guys. Here we go. Being able to sketch in our angle based on those special right triangles. So the 45, 45, 90 and 30, 60, 90, looking at those two orientations of the 30, 60, 90 to be able to get our pi over 3 and our pi over 6 angles. So that's what we looked at. And then evaluating for sine, cosine, and tangent. When I consider all of those triangles and every possible rotation or reflection of them on the unit circle, right, centered at the origin with a radius of 1, I get what we call the unit circle. Okay, so this is the unit circle. Every angle that we have from 0 through 2 pi, or I should say all of the common angles that we'll use from 0 through 2 pi, labeled on here with our coordinates for each of those corresponding points on the circle based on that angle. And what I want you to notice is that this guy right here, this pi over 6 angle, right, would be the same angle just reflected to get 5 pi over 6. The only difference in the points is that for this point, the x value is going to be negative because we're on the negative portion of the x-axis. I could also take my pi over 6 and reflect it down here, and that would be 11 pi over 6. Okay, it's the same angle, the same measure, it's the same distance from the x-axis. The coordinates then are going to be based on that same special right triangle, but this time the y value is going to be negative because down here we're on the negative portion of the y-axis. So I want you to notice that those signs of those x and y coordinates are going to change based on the quadrant that we're in. That should make sense. We've got negative y values, negative x values, and then positive for each of them. There's a little mnemonic device that you can use to help you remember if I'm in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. My functions, when I evaluate sine or cosine or tangent or secant or cosecant, what can I expect? Will it be positive? Will it be negative? What should happen? And that little mnemonic device is all students take calculus. I've also seen a very smart trig class, but I learned all students take calculus, and it follows the quadrants to tell us which functions we should expect to be positive based on what quadrant I'm in, based on what quadrant my angle lies in. So A, all functions are positive. That should make sense because everything in the first quadrant is positive. X is positive, Y is positive. So if I look at reciprocals or if I look at like ratios, I'm looking at all positive numbers. In the second quadrant, sine is positive, and that means that cosecant will also be positive. It's reciprocal. In the third quadrant, tangent is positive, which means cotangent would also be positive. And this should make sense that the third quadrant tangent would be positive because we're looking at a negative x value and a negative y value. When I look at a negative over a negative, we're going to get something positive. And then in the fourth quadrant, cosine, and then secant, its reciprocal, will be positive. We're looking at, for cosine, those x values, and our x-axis is positive here, where the y-axis is negative. For quadrant 2, I didn't say this, but our sine, right, is our y value, and our y values are positive here. Cosine would be negative here because the x values are negative. So just a little mnemonic to help us remember. So let's take a look at some more angles and sort of relating in these values from our unit circle. So on the next page, this is page 11 for me. We're going to go back to some more sketching, some more practice with where these angles should fall. So sketch the angle pi over 6. Pi over 6 is going to be in the first quadrant, and it's going to be closer to the x-axis than the y-axis. It's going to look about like that. Okay, there's my angle. And then I want to know what point does this angle correspond to in the unit circle. So again, I like to use those special right triangles to help me determine where my angles are going to live. So I'm going to drop a side down on my x-axis or to my x-axis. This is our angle, pi over 6. Okay, this is a 30, 60, 90 triangle because pi over 6 is our 30-degree angle. Our smallest angle is going to be across from our shortest side. Our shortest side in this triangle is a half. Remember, our hypotenuse for all of these is going to be 1 because it's the unit circle and the radius is 1. And so then this other side would be root 3 over 2. So then this point here would be the point, remember it's x comma y, root 3 over 2 comma 1 half. That's our point. So if I want the sine of pi over 6, that would be the y coordinate of that point, which is 1 half. If I've got the point, the rest of this becomes pretty easy. Cosine is just the x value, which would be root 3 over 2. And then tangent of pi over 6, remember, is sine over cosine. In this case, y over x. In every case, but as we're looking at our functions here, y over x. So my y value is a half over my x value, that's root 3 over 2. I've got to simplify this here. Since I'm dividing by a fraction, I'll multiply by its reciprocal. The 2's I can reduce, and I've got 1 over the square root of 3. Now, depending on the context, depending what it is that you're doing, you may or may not need to rationalize your denominator in, let's say, geometry. If you're taking the AP calculus test, I believe they do not currently require you to rationalize your denominators. But when we're working with trigonometric functions and trigonometric values, the custom is still to rationalize our denominator. So what that means is that we do not want an irrational number like the square root of 3 in the denominator of a fraction. It's irrational because the square root of 3, it would be a non-repeating, non-terminating decimal, right? So in order to rationalize this, what we're going to do is multiply by the square root of 3 on top and on bottom. This is okay to do because square root of 3 over square root of 3 is just 1. So essentially, we're multiplying by 1. We're multiplying by a very sort of odd and specific 1, but we're multiplying by 1. That's why this is okay to do. So on top, 1 times the square root of 3 is the square root of 3. And then on the bottom, root 3 times root 3 would be root 3 squared, right? It's a thing times itself. And then the square and the square root would leave me with just 3. So I have a rational value on the bottom now, and we'll say that tangent of pi over 6 is equal to root 3 over 3. For our remaining 3 functions, we are just looking at the reciprocals of the first 3. So cosecant is 1 over sine. That's the reciprocal of sine. So this would be 2 over 1 or just 2. Secant would be 2 over root 3. Again, I need to rationalize my denominator here. So we're multiplying by that root 3 on top and bottom. So that would give me 2 root 3 over 3. And then for cotangent, same thing. If you want to set up cosecant over secant here, you can get your cotangent, or we can just take our tangent and take the reciprocal. Again, I'll need to rationalize because now my root is in bottom. But we would get 3 root 3 over 3, and then we can reduce to just the square root of 3 there. We're going to do the same thing with our next example. So we've got a new angle now, 3 pi over 4. Let's figure out where that should live on our coordinate plane, 3 pi over 4. So remember we started 0, and then pi is here. So 3 pi over 4 would be somewhere in quadrant 2, right? This would be our halfway to pi, so this would be pi over 2. So we could divide these further into fourths, and we would end up with 3 pi over 4 right in the middle of quadrant 2. Okay? So there's our angle. And then for reference, we are going to look at this triangle here. Okay? We are always dropping down a side to the x-axis. We are always taking a side to the x-axis to get that sort of reference triangle. And then this angle that we're looking at would be a pi over 4 angle. So this whole big angle is 3 pi over 4, but our like reference angle here, we call it, would be pi over 4. So we're looking at, from last time, 45, 45, 90 triangle. We know our hypotenuse is a 1. That would make our sides root 2 over 2. This is root 2 over 2. Now, keep in mind, I'm talking about the side lengths for these triangles. When I translate that to the point on the unit circle, I have to keep in mind what quadrant I'm in. Since we're in quadrant 2, that means this x value is negative. So I've got negative root 2 over 2, and my y value is positive, comma, root 2 over 2. So this corresponds to the point, negative root 2 over 2, comma, root 2 over 2. And then my sine would be the y value, root 2 over 2. My cosine is the x value, which is negative root 2 over 2. And then tangent is the ratio of sine to cosine. So root 2 over 2 divided by negative root 2 over 2. This up here a little bit. So this would be root 2 over 2 times negative 2 over root 2. And I have a whole lot of reducing I can do here. And we end up with negative 1 for tangent. For our next three values, we're just looking at the reciprocal. So this would be 2 over root 2. And then again, rationalize our denominator. So we get 2 root 2 over 2. And we could reduce and just get square root 2. For secant, it's going to be the same thing but negative. So negative root 2. And for cotangent, 1 over negative 1 is just negative 1. So we've got just a couple more that we're going to look at here. Again, we're practicing sketching in that angle and finding that corresponding point. For example, 6, 17 pi over 6. Now this angle is a little bit different because it is greater than 2 pi. So we're going to rotate around more than once. Okay. To figure out how far around I go on that second rotation, I'm going to take 17 pi over 6 and subtract 2 pi. Okay. I'm going to subtract that one full rotation. So if I change this to common denominators, that'd be 12 pi over 6. When I subtract, I would be left with 5 pi over 6. So I'm going to do one full rotation, and then I'm going to end at 5 pi over 6. This is going to be in quadrant 2. If I forget about the pi for just a second, 5 over 6 is just less than 1. And my pi is essentially my 1, right? I'm at almost pi. So we're at almost pi. That would be here. Again, quadrant 2 closer to the x-axis than the y. So we'd be about here. And my angle that I've drawn is actually that. But the angle that we're going to use for reference would be, this would be an angle of pi over 6. So I'm going to drop down my side to the x-axis to form my triangle. This would be a 30, 60, 90 triangle. So the short side is a half. My hypotenuse is always 1 when we're on the unit circle. And then my side here would be root 3 over 2. When I translate that to my point, my x value is going to be negative. We're in the second quadrant. So that's negative root 3 over 2. And my y is positive 1/2. Now sine and cosine are easy. Sine is 1/2. Cosine is negative root 3 over 2. Tangent is sine over cosine. So we would have 1/2 times -2 over √3. The 2's are gone, and we've got -1 over √3, but we're not going to leave it like that. We're going to rationalize our denominator by multiplying the top and bottom by square root of 3, and we get -√3 over 3. -√3 over 3. For cosecant, we're looking at the reciprocal of sine, so that would be 2. For secant, this would be -2 over √3, which again, we need to rationalize. So I would have -2 √3 over 3. And then for cotangent, we're looking again at the reciprocal of tangent. So that would be -3 over √3. Rationalize here, and we get -3 √3 over 3. We can reduce the 3's, and we get -3 for our cotangent. One more example to look at together for today. -pi over 3. This one's also a little bit different. We're looking at a negative angle this time. So instead of counterclockwise, we're going clockwise to pi over 3. So we're going to be down here in quadrant 4. And then pi over 3 is going to land us closer to the y-axis than the x. So we're going to be kind of in here like this. Okay. So that angle that I've drawn would be clockwise, right? Since it's -pi over 3. And then I'm again going to drop down my side for my triangle. And my little reference angle here, if we think about our special right triangles, would be 60 degrees. So my hypotenuse, again, always 1 when we're talking about the unit circle for that hypotenuse, since the radius is 1. My long side would be √3 over 2, and my short side is 1/2. So that means when I translate this to my point, my x coordinate would be positive 1/2. My y coordinate, though, we're on the negative portion of the y-axis, would be -√3 over 2. So sine is -√3 over 2. Cosine is 1/2. Tangent would be -√3 over 2 over 1/2, which would be -√3 over 2 times 2 over 1. The 2's reduce, and we're left with -√3. Cosecant is the reciprocal of sine, so we have -2 over √3, and we're going to rationalize. So that gives us -2 √3 over 3. Secant is the reciprocal of cosine, so that is 2. Cotangent is the reciprocal of tangent. That'd be -1 over √3. And one more time, we need to rationalize here. So we get -√3 over 3. I suggest, even if your problem doesn't specifically ask you to sketch in your angle, that you sketch in your angle and drop that side to your x-axis. So you could take a look at your triangle and decide the values for the sides. Do they make sense for the point that I am saying corresponds to this angle? Always a good idea to sort of tie it back to stuff that we know, so that this new little bit more abstract idea makes sense and has some foundation for us to sort of grab onto.